Right, float point numbers. These are easy and hard to get your head around. So these are in binary, and they are a way of making things look pretty. That is the only use I can think of for them at this point in life, that they look pretty. So, what actually is float point numbers? So basically, any decimal number can be written in the form of a number multiplied by 10. So this 1.7 can be written as 0.17 times 10 done. So this technique can also be used to represent binary numbers, so that is obviously binary 4. This could be considered with stuff such as, for example, the number 7.75. Obviously, it goes 8, 4, 2, 1, point, and then a half, a quarter, an eighth, a 16th. Let's just leave it as 8, as in 8 bits. So that would obviously be 1, 1, 1, 1, 0.1100. So obviously I see nothing wrong with this, but the people who don't like it like this, they want this decimal point right here to move 1, 2, 3 places that way. So when you move 3 places that way, that would mean that'd be 0.111100. So this is called the Mantissa. I think that's how it's pronounced. So that's called the Mantissa. But obviously, this still needs to be able to represent the original 7.75. So because of that, you also have to write the exponent. So the exponent in this case would be, as you have moved it 3 that way, well, you have moved it 3 to the right, so to fix it again, you'd have to move it 3 to the left. So the exponent would be, well, the exponent is normally 2 to the power of something, so in this case 2 to the power of 3, or just 3, or in binary terms, that'd be 0011. And that is basically because 0011 actually means 3, and that 3 would be these 3, this decimal point moving back 1, 2, 3, or these numbers getting moved forward 1, 2, 3. And that is literally floating point numbers. So you can use these to be able to both add and subtract. Oh, this is normalisation, isn't it? Oh, no. Actually, no, I can get away with it. Okay then. Normalisation is the process of improving the accuracy of a number with decimal points. Oh, that is normalisation. Well, I've just effed it. Okay, it doesn't matter. So that was, well, it's still the same thing, but floating point numbers is still the decimal, and then normalisation is obviously the process of moving it. So technically I have still done it. So now, stuff such as, say you were to use normalisation, etc., and you were to do the numbers 20, let's not do that, let's just do 7.25 minus 2.25. So how would you do that? You would do 7.25 plus minus 2.25. So how would you get this minus 2.25? You would obviously do minus 8, 4, 2, 1, and then a half and a quarter. So here would obviously be 1, and then you would use numbers to be able to fill up the rest of that place to be able to make it work, I guess. So that would be 1, and then, so that's minus 8 plus 4, not 0, plus 1, plus a half, plus a quarter, and that is the way of doing minus 2 point, rather that, and then 1.75 is obviously 0, 1, 2, 3.01. So that is that one, and this one is 1101.11. So if we were to put this into the exponential Mantissa format, so normalize it, this would then become 0.11101, and then it would be, so as this has moved 1, 2, 3, it would move 1, 2, 3 back, so it would be 0, 0, 1, 1. And this one would move 1, 2, 3, 4. So it would be that, and it would be 1, 1, 0, 1, 1, 1. And I think that would be 4. 1, 2, 3, 4. Yeah, the decimal point would move 4. So, therefore, this is 3, and this is 4. To be able to make this work, this would be moved to 0.11101, and then this one would be moved to 1.10111, and then you would add them, so that would be 0, 1, 0, 1, 1, 1, 0, 1, 1, 0, 0, 1, and that's your answer. And that is normalization, left floating stuff, and addition.